Welcome back to a whole new episode of What About AI? We're exploring how AI is reshaping the world. I'm your co-host, Breon Martin.
And I'm Pascal van Hentenryck. Good to see you again. Today we're going to talk about AI and mobility. How do we design cities, how we go around in cities, and the impact that AI, autonomy, and data has on mobility in general.
Autonomous vehicles are all over Atlanta, and to talk a little bit about that, we have Srinivas Peeta, who is an expert here at Georgia Tech, who's going to give us the rundown and talk about AI.
Hi, Breon. Hi, Pascal. How are you?
Good.
Hi, Srini. I'm super excited to have you here and share your time and expertise with us. I have also been working in mobility. We work with Marta, we work with the Savannah Transit System, we work with Union Pacific, Ryder, and I'm really, really interested in having your take on this whole field of AI, autonomy, mobility, and in general cities, because the impact on cities is going to be substantial potentially.
So before we dive into all the technical questions, beyond your resume, how did you get into technology? A little bit about you.
I did my doctoral work in transportation systems broadly. And this was at a time when there's a whole new area called intelligent transportation systems that was coming online. And this was towards the end of the 1980s, early 1990s. And at that time, technology started seeping into transportation solutions and applications at a level which seemed particularly innovative then. And then over a period of time, there have been a lot of new discoveries, innovations, and inventions, starting with all the information and communication technologies that took place in the mid-1990s and so on. And then in the early 2000s, we had autonomy and automation show up as well, and then connectivity in transportation. And since then, all of these have kind of converged towards new modes, emerging modes of transportation. So we are in a very exciting time when it comes to transportation, both in terms of the use of technology and in terms of the types of modes and types of systems that are being thought about going forward into the future.
Yeah, it's amazing. I mean, I was discussing with my wife the other day and saying, okay, so now we want to go to some place in a city, just use the GPS and you can follow. Or if you don't want to drive, you call a Uber or a Lyft. It's like, we could not have imagined this like 30 years ago.
Absolutely not. And I remember the first GPS systems that we used to have in our vehicles, and those used to have what are called static traffic networks, which means you didn't know where the congestion was. All you knew was the route.
So, exactly.
Yeah.
Oh, wow. Yeah, I couldn't even imagine living without my GPS. I mean, the integration is so good that it even suggests things on my route that I typically go to. Like if I'm coming to campus, it'll say, you want to run a target really quick?
Yeah. That's interesting.
Yeah.
And so Srini, from a research standpoint, I mean, you have been to academia for a long time. It must be super exciting to be in transportation, right? So this is a field that has been evolving fundamentally because of technologies. And how did the community adapt quickly to these changes? Because, you have your stream of research and then suddenly a new technology appears and then, what do you do?
And that, the first thing, we are in a rather exciting time when it comes to transportation. And as excited as I was in the late 1980s, early 90s, when technology, when you talked about technologies, then it was advanced traveler information systems, advanced traffic management systems, which means sensor systems, information systems, and so on. When you look at what we are seeing over the past decade or two, we are talking about a fundamentally transformative and disruptive scenario here, where in many ways the human is going to start ceding control of the driving. And this is something that's been going on for the past century now. Yeah. And so that shift is what has become particularly exciting in terms of, how the human and the vehicle and the infrastructure, all of these interact, and what are fundamentally emergent, challenges that are showing up as a consequence. So,
absolutely.
Atlanta obviously has its unique infrastructure and its city in general. But when you see the autonomous vehicles and just the growth of what's going on in Atlanta, what's going through your mind?
It's pretty satisfying that these systems, autonomous systems, the robo-taxis like Waymo are coming into the Atlanta area. Of course, they have been there in a few others like San Francisco, Phoenix, LA, and Austin, and so on. And there's no reason why Atlanta shouldn't be another, if you want to call, location where they can test out some of these technologies. Because in many ways, what they do in terms of learning from one location, they actually can use that in other areas. And in many ways, those things are used to enhance the robustness of these technologies and how user-friendly they can be made over a period of time. So
let me dive into this.
Yeah,
sure. A lot of questions.
Yeah.
So the first thing that comes to mind is Atlanta is very different from San Francisco. The drivers are different. The roads are different. So how much of a challenge is that going to be for a company like Waymo? They come here, you have a mixture of congested highways. I love Atlanta, don't get me wrong, but congested highway, small roads when there is essentially, no sideways, drivers that, can cut you anytime. So how much of a challenge do you think it is for Waymo to actually deploy here in this city, which is, I believe, much more complicated than San Francisco and where Waymo has been deployed in San Francisco or Phoenix?
Sure. So Phoenix, and if and that's an important point. You're right. Yeah. Phoenix and San Francisco may be a little more friendly in that sense. Yeah. But if you look at it from the perspective of deploying in, say, New York City, which has very aggressive drivers as well,
but then they're not yet in New York City.
Yeah.
Right?
So they're not yet there. And part of the reason, and that's so if you look at where they are deployed mostly, they are deployed in areas which are weather friendly, if you want to call it that. Exactly. And that's not surprising at all, because you want to start having a limited level of control on your systems, trying to understand where the challenges are without introducing other complicating factors like weather. But they're slowly starting to look at the northern part and the Midwest as well going forward. But, coming back to where some of the challenges are in the Atlanta area, yes, Atlanta has a lot of traffic, and we see that, especially if you look at the downtown connector, the area around Georgia Tech seems to be congested almost all the time. Yes. And yes, there are drivers who are very aggressive as well. And Waymo, I think, has been, over the past year, it has been mapping this whole area, because what they've been looking at is which infrastructure, you mentioned narrow spaces, and then there are no, there's no recourse. There's no, there's one lane and that's it, and you can't do much beyond that. So I guess part of what they've been doing is they've been mapping that and trying to see where some of the challenges would be, and trying to see, and whatever they learn there, actually, in my view, would go to the broader understanding of how to improve their system, their autonomous systems as well.
I think you make 2 points that are very interesting. One is the mapping, that they come to a city and they start mapping the city, and this is what they have done in San Francisco for like 10 years or more.
Right.
And that's what they have been doing in Phoenix, which is easier because the streets are like wide, and there is almost no traffic in comparison.
Yes.
So the mapping is something very important. And then you said another thing which is important, in that you believe that the systems are improving over time. They get in this new situation and become more robust.
Right.
Now, I want to, and so
sure,
amazing. So one of the things that I'm always wondering, and I'm very curious to have your take on this, is that if I go tomorrow to a city that I have never seen, let's say I go to it's tough to say. Let's go. I go to Miami. I've never been in the center of Miami. So assume that I go there, and that I rent a car. I'm gonna drive in Miami without any issues. I'm pretty sure, right? Even if I go to Napoli in Italy, I have been driving there. I didn't need to map anything, right? So obviously you have to take care of the drivers there that are even more aggressive. Traffic lights are more recommendation than anything else. But the key point is that as humans, we don't need to map. We come to a city and we can drive. So how do you explain this gap between the capability of humans to actually go anywhere and drive? I mean, maybe it's a little bit different in Australia or Japan or, England, because you drive on the left. But other than that, we can drive essentially anywhere.
Sure. So in many ways, what you just, the example that you used, illustrates a dichotomy in the mechanisms. So first thing is, as humans, we have context and situational awareness. And this, in my view, that's something that we learn from birth. Somehow or other, we keep on putting things inside somewhere, which we can pull out at some point when the context arises. And beyond that, we have human drivers also have experience, and experience does count over a period of time. And then we use common sense. So all of these illustrate, to me, the sophistication of the human brain. And whereas if you look at these autonomous systems, they go with data. So what data they're trained on or what they have been exposed to. the sensors that are used to get a sense of the surroundings, so the situational awareness, and then the algorithms and the AI and all that goes into determining how they navigate and what are the next set of actions, the motion planning and so on that they do. So the dichotomy comes in the sense that these systems have difficulty in understanding the context, the dynamics, which human beings intuitively are able to resolve when they're faced with new situations. And I guess that's where the challenge is. And that's where there is the need to do this, the front end of the work that they do when they come and map and do other things, even if they don't do map. There's a lot of things that they're actually trying to resolve in terms of understanding where some of the challenges are. Because many of these systems, they work pretty well in what is called the situation when it's normal. And they're also called the boring mice, which what that means is where they don't learn anything new. So they can do very well. And that's been something that I've been doing very consistently for a period of time now. Where they face challenges is what are called the edge or corner cases that they call, which are cases that these systems, when they encounter, face challenges which potentially human drivers will not necessarily face. And that's where that dichotomy in terms of the approaches that are used. And I guess in some ways what we're talking about is human intelligence is at a level that we haven't been able to replicate in these autonomous systems yet.
At this point.
At this point.
So, yeah, building into this, I think there is also the question of when we drive, we still interact with human beings. So you come to an intersection, you see the eyes of another person, you kind of anticipate somewhat. Do you think we can build system that will have this kind of level of understanding? I see the eyes of the drivers coming in. Is he going to stop or is he going to continue? You have, as human, some understanding by looking at what the face and so on, what this particular driver is doing. So do you think we can get there?
Yes, and in fact, I'll mention some of the research we are doing is trying to get these autonomous vehicles to be what are called human-like to a certain extent. And that, direction of research started because we saw the gap. So where, human drivers are, or not just drivers, pedestrians and so on, there are interactions that they have with other human drivers or pedestrians, and there is an expectation what another human driver can do. Exactly. When we drive, there's an expectation of how the other human drivers are going to drive. And it's that expectation that leads to the comfort that humans have when driving in the vicinity of other vehicles. Yeah. With autonomous vehicles, that's where the gap is, because the way they drive is not necessarily something that humans intuitively expect.
Exactly.
And that's where we saw the gap, and we said we need to look at coming up with approaches where we can get these autonomous systems to be more human-like. And the starting point for that is that right now we have mostly human drivers. And then going forward, we'll have the transition period where we'll have some autonomous vehicles and mostly human drivers, and hopefully a future where it's mostly autonomous vehicles doing the driving. Now, this transition period can be one which is particularly conducive to having autonomous systems adopted, or it can be particularly disruptive where people say, well, I can't trust this system. And this is where, if we can get the friction reduced or get the human drivers and autonomous systems to be more harmonious, we can actually get these systems to be adopted more smoothly into society. And that's the starting point for having this notion of what human-like is. And you give a good example of human-like, where human drivers or human users, pedestrians, in the system, they're accused that they share rather, intuitively.
Human.
Yeah, and so what that means is if I'm crossing the road and if I see a human driver coming and slowing down, I know the cue is they're going to stop. And if I see an autonomous vehicle coming fast and then abruptly stopping, it will still stop, but I may be very nervous and I may say, I don't want to do that. And these are just simple examples of what human-like would imply. And part of it is also going to, when you talk about human passengers in autonomous vehicles, you can have autonomous vehicles which can be pretty jerky, which means they can have abrupt starts and stops. And that's not how humans feel comfortable riding in a vehicle. On the other hand, if you have jerkiness reduced and have smoother accelerations and decelerations, then the humans feel more comfortable. That is another example of what human life could imply.
So you want human driving.
Yes.
So I think that this is very interesting. So in a sense, this transition is actually more difficult than a world where there will only be autonomous vehicles. So
Exactly.
the transition is the hard part.
Exactly.
This is very bizarre in a sense. You could say, we stop it. Nobody drives. You get this autonomous car to take you from places to places. That would be very different. There is this debate really about the different way of actually, implementing this autonomous car. And you have, one approach, which is I only need cameras, right? So that's
right.
where I'm coming. And there is another approach, not naming anyone, where you say, we need camera, but we also need, LiDAR and
Yes,
and
others.
yeah, exactly. And so I have two questions for you. Is there some kind of, you are, an expert in the field. Is there consensus of where the field should be going? So question number one. And maybe we don't know the answer yet, but that's one of the things which is always in the back of my mind. And question number two, when I talk to people, doing the radar technology, they say currently it works well because you don't have that much interference with them, because there are not that many autonomous cars. But no, assume that you have, hundreds of thousands of them in a city like Atlanta.
Right.
Can these radars still work in an environment where you have massive number of them? So, you're the expert. I'm really super keen to actually try to get an answer to those two questions that have been at the back of my mind.
Sure,
like 6 months.
Yeah, I mean, I guess the first one that you were mentioning where, use cameras and AI, that would be the Tesla model, if you want to call it.
Yeah,
And the other
I
one-
didn't want to name anyone.
Yes, and then the other one is the Waymo one. There's a few others.
Exactly.
And, I'm not sure that has been answered, that debate has been settled.
Yeah.
But I do feel still kind of worried, if you call it that way, where only cameras could handle everything. And I'll give my reasons why. Even though Tesla says that that's all they need and massive amounts of AI and all these advancements in AI that can be used to do that. But I'll just give a few contexts here. There have been situations in the past, of course, where with the use of cameras only, there have been fatalities as well. I don't know if you remember a few years ago that happened. So they may say that that has been addressed. But going forward, one of the things that human drivers are able to do rather easily, where some of these systems have had challenges, is when we have, say, a first responder type situation. So you have sirens in the background. Human drivers, when they listen to that, they know that they should be prepared for, the downstream scenarios which may not be particularly conducive to normal driving, which means there may be things that have to react to pretty quickly. Whereas if you look at these vehicles which are only seeing things, they're missing out on some of the other senses. When we talk about the human brain and so on, we're talking about the auditory side. We're talking about sometimes even smell. What happens if there is a chemical spill? People can smell, or there's a fire, they can smell, they can prepare, and so on. These systems, until they get there, they probably, unless they use other types of sensors, they'll not be able to get a feel for that. And so we have seen some of the challenges that are arisen as a consequence of that. Now, coming back just to whether cameras alone will do, or it's good to have redundancies in terms of LiDAR and others, my feeling is that at this point, given where the field is, given the level of maturity of the systems, in order to ensure not just safety, but also that we don't get into situations which humans find puzzling, where these vehicles suddenly stop, I do feel that it is useful to have as much redundancy as possible. So having these, this radar, LiDAR, and so on, in my view, will add this extra layer of, reassurance. Reliability, robustness, that which we haven't gotten to the point there where we can say we have level 5 automation, where you don't need steering wheel and pedals and all of that. We haven't gotten close to that. That's why I would kind of, personally, I would tilt a little to that. But I don't think the debate has been answered. If they're able to illustrate that at some point, fine. But I'm not sure that has been done yet.
What I read is, situations which are not the normal situation.
Exactly.
Like you were saying,
Yes.
bad weather,
Yes.
fog, things that are smoke, things that are not usual.
Not usual.
And that, the camera may not be very good. But then radar will tell you, hey, watch it,
Exactly.
you are driving there, but there is a car there.
Exactly.
You don't see it.
Yes, exactly.
So
And
that's
so
the kind of things that I think,
where
it's a redundancy that gives you more robustness.
Robustness to the
Fundamentally,
Yes.
you want this system. These are engineering system.
Exactly.
You want it to be as robust
as possible.
Yes, very, very nice, very nice. And the interference between different radars, do you think that's an issue? Or?
I can only tell with my experience with, in the early 2000s when the U.S. Department of Transportation, they were kind of pursuing this notion, and they're still, it's called connected vehicles. I mean, there's a whole system of where vehicles can be connected, they can talk to each other.
Yeah.
And through that, they can enhance safety, robustness, efficiency, all of that. Now, even in that context, of course, there are technologies there as well that are being traded off, where they have the cellular versus, the other ones that was there previously, DSRC. So they were trading off all of that. And one of the things that we were trying to model that and see what happens if, you talked about tens of thousands of vehicles in a traffic stream having these technologies. So even there, when we had these devices that could receive and send information, having so many of these talk to each other or send information simultaneously, we actually have studies which show that the information or data can get damped out.
Interesting.
So we actually have papers that have been published where we actually try to go to the networking domain, the specialist and the networking domain to see. But even at that point, when we were trying to see whether we could do better, we were at the limit of what their knowledge was as well. But one thing was very clear. If these vehicles were simultaneously sending information or data across, a lot of the data would be lost. And if that were to happen in a safety critical situation, then we would actually not benefit much from this. So going analogous to the point you raised, I would see that as being a potential issue going forward.
Potentially.
Oh, yeah, definitely. So,
yeah, I mean, the Wi-Fi technology, this was all about removing interference.
Yes, exactly.
The big breakthrough that came from Australia, actually, was being able to cancel the interference sources. So I think they will need to think about whether
that.
There is a solution when you have so many vehicles on the road.
Exactly.
Very interesting, very interesting.
Definitely. I wanted to go back to making these self-driving vehicles more human-like. Every time I get into my car, I have a unique experience here in Atlanta. So I can't even imagine just getting into one of these vehicles and going to a game, being dropped off, being picked up, and then there's so much traffic, there's so many people walking around. Where do you feel we are when it comes to these vehicles kind of managing those kind of like expectations on how am I going to maneuver out of this crowd?
And so that's where, again, we see the difference between the human driver and these vehicles. And just to give an example, if I have a single lane road, so we have opposite directions, we have traffic, there's a yellow line, and let's say there is a bicyclist going. A human driver would just go around the yellow and then get back. If they see that in the other direction, they can actually safely negotiate. Now, unless these systems are allowed to do so, they simply will hold back, and that will lead to a bottleneck that gets created, right? And that is one of the challenges. And similarly,
because it's safer.
It's safe, and it's the rule. I mean, they're not allowed to do that. Yes, and so that's why I said more human-like. Some of that would be a good example of what more human-like would be. Another example of that.
So this is actually a very interesting example because when we do something like this, so we are behind a cyclist and we want to overtake, we try to see who is coming on the other side.
Right.
And as humans, we have a very good idea on how fast that car is coming.
Right.
If you have only a camera, can you detect that? Do you need a radar? Can you do that? Do they have the capability to do that? That's the kind of things that is very interesting, right?
Right. On top of that, they should also be able to cross the yellow as well. I mean, so that's the other thing.
Absolutely.
So that's, so humans know when to do that and when to do that, in the broader sense that they're actually helping the situation. Because otherwise, we have seen situations where some of these vehicles just go so slowly and then there's this bottleneck that's created, which could easily not be, which would be completely avoided if it could. So that's one of the things. Similarly, when you have merge areas, and you see, you talked about Atlanta traffic, that's where if, human drivers, they'll get somewhat aggressive at some point and try to, get their way in there, weasel it in, and then they know that the vehicle behind will, stop and then, or at least let them in. With a autonomous vehicle, they may, because they're more risk averse, they have rules. They may just hold off there. And these are situations that have been observed in the past as well, and that they create a bottleneck. So there's a whole bottleneck that's created out there. So coming to your question about where and how the challenges are, some of the things that they can handle pretty well. I mean, in the sense that they're going to be very careful around just not just human drivers, but pedestrians as well. So they're going to be a lot more patient, if you want to call it, and not move as fast as what some human drivers would expect. And that may lead to, if you want to call, I wouldn't say road rage, but it'll get frustrations on the part of the human driver saying, you got to, get on with the show, kind of, because otherwise we're going to have challenges in getting the traffic moved out.
Yeah.
But beyond that, if you have, stop and go traffic, these vehicles should go, completely fine because they're just reacting to the vehicle in front of them. They're, in a situation which is crowded, but they know what their surroundings are. So
yeah, I can't even imagine like one of these vehicles honking at someone to move, like at all. Would that ever be a case? Because if a camera does capture someone just obstructing traffic just because, or just standing in the way because it's a cool car and recording a video saying, "Look at this, guys." Is there anything that the vehicle or any indication do you see coming from the technology saying, okay?
What I can think of, just based off the example that you gave.
No.
Based off the example.
This is an example, because this probably happens.
Nice. I mean, if it happens that way, one thing that we could easily see is they could connect to law enforcement. And then connect to in real time and have this resolved in reasonably, reasonable type, if you want to call it that. So there is that potential. That's why we say when you talk about autonomy, we also talk about connectivity simultaneously. That's why we talk about them as connected and autonomous to get the full range of capabilities of these vehicles, actually.
Because there's so many scenarios out there that could happen.
But that opens an different Pandora box, because now we talk about the information that these vehicles are collecting. And as you know, some of this has been used by law enforcement, that typically data that they would not have otherwise. So there is a whole privacy issue now, which is coming from the data that these vehicles are collecting in real time. So again, this is like every technology.
You're right.
Good uses and bad uses.
Right.
So, can you comment on that and the way the field is reacting to that? If this is becoming a main issue, like they are collecting a lot of data on people, a lot of data on driving patterns and so on.
I'll go in two directions here. One is privacy.
Yeah.
The other one I'll go is security, actually.
Yeah.
So on the privacy context, at least this is my personal view. If you want to have benefits, to the fullest or to the extent possible from such technologies, it makes sense that data which is previously constituted as private, I mean, with sufficient, I would say, firewalls where you anonymize the data and so on. We should be able to use it to the benefit of society, in the sense that we have all this congestion on a regular basis. If getting all this data and coming up with solutions in real time that can help diffuse some of that, I think the trade-offs that exist there are particularly beneficial. In fact, I remember there was a case at some point where at intersections when they had cameras and then someone said that their privacy was violated, the judge was saying that this is public space. So if you go through that is data that's collected. It's not particularly targeting anyone, but it is collected for a benefit of, the traffic situation. So there are these arguments that are there. But what I would say is if one is focused primarily just on privacy and saying that privacy is the only basis by which we move forward, a lot of the potential benefits that we can get from such systems would be limited.
Yeah.
Mm-hmm.
So that's one. On the other hand, if you talk about it from the perspective of security, in the sense that if this data can be maliciously used, that becomes a whole different question to address, and that's where standards, protocols, and things like need to be addressed very carefully, to the extent that this doesn't fall into hands where they have malicious intent, if you want to call it that way. And related to that, there's this whole issue that when you talk about autonomous vehicles, you're talking about machines, they're robots or whatever it is, and there's the ability to hack them. And so there is this whole cybersecurity issue that arises, and we're actually studying some of that in our driving simulator lab right now. We're trying to see whether people can perceive if such vehicles have been hacked, and if so, what are the consequences, and how do you interact if human drivers interact with such vehicles. And so
because I think you could drive one of these vehicles in a crowd of people.
Right, exactly. I mean, so
you don't have a driver; you just control it.
Yes,
I mean, there was.
we have seen humans doing that right now. When you talk about controlling it remotely,
exactly.
It's like a very I don't know, with a weapon of mass destruction to a certain extent possible, actually. Yeah.
So this is fascinating. I mean, your field should be moving in so many directions and actually interacting with so many different fields now, because you need to be an expert in transportation, in AI, in privacy, in security.
Security, and blockchains, all those things. I mean, you talk about it,
Yeah. So you must be pretty excited too.
Oh, we did. And when you see our students, going, in many ways, it's organically done.
Yeah.
When the need arises, they go and, go into depth into those areas. You feel that satisfaction that they see the, first thing they get to be experts in those, but they're not experts in any one field only. It's a convergence based on the problems that they are addressing. So you see these students who are now specialists in multiple domains.
Yeah.
Even in AI, when you look at it, you talk about deep learning, you talk about, physical AI, you talk about explainable AI. So there's a whole bunch of different dimensions that they're trying to look at based on the problems that they're facing. And some of them arise because the data that we collect has such diversity in terms of the sources, in terms of the characteristics. And what we are seeing is that in order to fuse the data, there's the need to go beyond some of the traditional methods that have been there as well.
So this is very system engineering.
It is.
That's very interesting. So this is something that started emerging because of AI.
Yes.
And in many different, disciplines that used to be completely independent.
Exactly. Exactly. And so for us, it seems very natural. And I remember having conversations with people who are experts, even in machine learning, who said, the applications your students are addressing, we have not yet addressed the theory for that. I mean, so we are seeing that some of the challenges, and this makes a lot of sense, because in the real world, you're talking about systems which are pretty complex and advanced. There is a lot of dynamics involved. And when you talk about vehicles, tens of thousands of vehicles, you're talking about human behavior, you're talking about vehicular technologies that are diverse, all of them interacting. But I also will say that we have been leveraging some of these to, in a positive way. For example, when we have vehicles changing lanes, typically that's a situation which is a little more safety critical, because they are go to the other lane, make sure there's a gap and all of that. And what we are seeing is, if we can have these autonomous vehicles play the role of a moderator, that is, if somebody is, as you said, they're very aggressive driver, they really want to do the lane change, even if it seems unsafe, they can play the role of slowly easing the conditions, in the sense that they back off, create sufficient space, and make sure that whatever lane change is being done is done more safely than would otherwise be done if you just had human-driven vehicles. So we can actually use AI and these autonomous systems in ways which can help the situation.
That's very interesting. That's very interesting. Because this, when you change lanes in the United States, you can have two different people moving like this, and this is super dangerous.
Yeah,
it is.
It's one of the things that worries me the most when I drive here in the Atlanta region.
Oh yeah, because you have 6 lanes, 5 lanes.
Exactly. And people can go. They can go. They can overtake on the right, which is not allowed in many European countries, for instance. And then you, when you move to a lane because you want to slow down, you don't know if somebody is actually accelerating somewhere else.
Yeah, and on top of that, at least what I've seen in the Atlanta area, there are people who don't see that there are lanes there. They just keep going across. They go this way, that way, they weave around. And that makes it even more challenging.
Yeah, blinkers seem like a thing of the past, unfortunately. I wanted to go back to talk about priorities. So when building this kind of mass project, what is priority? Is it the guardrails? Is it the infrastructure? Which one takes first, or which one is like high on that list?
So for the foreseeable future, what happens is, because we are we'll be transitioning, most of the infrastructure that we'll have is infrastructure that's been in many ways shaped by humans doing the driving, right? So when you talk about the infrastructure, a lot of it is that way. Now, when we talk about infrastructure, it's not just the physical infrastructure, but even the virtual infrastructure, or the other part of it, which needs to be handled. What I mean by that is the amount of data that we have to process. And some of these require solutions in rather, when I say flash of a second, millisecond, microseconds, especially when you have things like platoons, where decisions are taken related to safety and efficiency. Some of these solutions have to be done in almost, I would say, milliseconds, microseconds, and so on. So some of the challenges in terms of infrastructure are on the side which are on the cloud and in the compute side and so on. Now, coming to the other one, in terms of how the physical designs are, that is part of something that we have also looked at and see. And what we have, at least what we have done in an area called Curiosity Lab, which is in Peachtree Corners in the northeastern suburb of Atlanta. And what we have seen is we have created a digital twin, and we have seen whether some designs are more conducive to human drivers being more comfortable with these autonomous vehicles. And we see that there are some types of designs which make it much more comfortable for human drivers to understand the intent of these autonomous vehicles. So we have seen it there on that side.
So this goes hand in hand.
It goes hand in hand. So what I say is there is this interaction between the infrastructure, the technology, which is the vehicle, and the human. And my feeling is that we have to simultaneously look at all of them, because human behavior is dependent on how the infrastructure is, but also how the vehicle is responding as well.
Okay.
So all of these go hand in hand, and the interactions we look at between humans and machines or humans and the vehicles become as critical as what type of infrastructure we need going forward as well.
I guess I was looking at it as simple as like building an app. There's a lot of engineers and research scientists who build apps without thinking of the ethics. They think of, I want to build this cool technology, and then that comes later on. So, but it's not the same.
Cool.
I'm like,
If you want to talk about it from the ethical side, you're talking about building an app and so on. But there's ethical questions have existed in the context even of autonomous systems for some time, right? Now, because they when faced with situations which are no-win situation, what is the best course of action is one of the questions. And the question is, how do you resolve that? And there have been all these studies that have been done, but those are all very specific contexts which may not arise most of the time. But nevertheless, these are questions that happen, because if I'm a human driver, I choose to do something in the end. Whether it's the right thing or not, will be shown later, whether I'm allowed or not and all of that. So and what happens to the others. But there are these questions that arise in terms of which causes, I guess, more harm, which causes less harm. And some of these are not particularly, what I would say, easy questions to answer, because you can have millions of situations which are rather specific, which may not be particularly commonplace, right? But which can arise. And that one situation where things, work out really badly for the autonomous system is highlighted, and that may be a cause for, stepping back and so on. So that's why it's important to try and see how we can address situations which are not commonplace, business as usual type situations. And that's why a lot of what these companies do when they incrementally try to expand the area in which they operate is to try to avoid situations where they have especially safety-related implications.
I think we can step back a little bit and explain this to the audience, because I think it's one of the big ethical issue in autonomous cars is that if you are in a situation where if you go straight, for instance, you're going to kill everybody in the car, or if you just go right, you will kill a pedestrian. What do you do in those cases?
That's the problem.
That's the kind of ethical issues that the systems are facing. And I think I agree with you, Srini. I don't think we have an answer to that.
Yes. Yeah.
I think, even from a human decision-making standpoint, I don't know.
Still difficult.
In a snap second, how we do that decision, how Breon would do that decision, or how different humans would do that.
That raises a very important question there, and that is, do we hold these autonomous systems to a higher standard than we do humans? I mean, that's part of the question, because there is the expectation of, these are autonomous vehicles. If people were not, more knowledgeable, they would think, these should be able to do everything. And that's part of the reason why when Tesla named them their system an autopilot, there was an expectation that it should automatically do everything, which it couldn't even then.
Yeah, absolutely.
And that's led to some of the issues that showed up. But the question is, should we hold them to higher standards, or is it okay if the wins that we gain? Because if you look at the number of fatalities that are caused by accidents on the road, there are about 40, right now I think around 45,000 annually in the US. What happens if we can reduce them to, a few thousand? Is that a win? And, for me, that would still be a win, because we still will have about 35,000 odd people would still be alive.
And that's always the big dilemma between expectation and then a specific case that concerns you, right? So in expectation, yes, we will be more safe.
Yes.
But when you have a particular case, people are going to look at that particular case and say, hey, a human would have done a different decision.
Yes.
So I think this is very difficult. And this is also the case in many of the AI technologies.
It is.
So, for instance, in medicine, the doctors and the AI systems are complementary to each other. They don't necessarily see the same things.
Right.
And so I think this autonomous car is probably going to be the same. They may, in this situation, do something different, and sometimes it's going to be better, sometimes it's not going to be as good.
Right.
I think we will definitely avoid, people getting tired and having accident because of that, or drunk driving. These cars don't drive. Right.
Yeah.
So I think there are a lot of the causes of accident that could be removed.
Yeah, exactly. Immediately they could be removed. Beyond that, as the systems become more commonplace and as we have more and more data, we'll understand better how these systems should ideally react, and then build those answers into their systems, and hopefully reduce over a period of time the cases that would otherwise make people uncomfortable.
So I think you have a very optimistic view of the field in a sense. This idea of the systems are going to learn and learn and learn. So I think it's a very interesting take that on the field, that the more these systems are going to be deployed, the more they will learn, the safer they will become. So
And then this is something that we have seen, for example, in the air transportation system. When you saw the first people flying versus where we are now, and there was a period of time, I remember, in the commercial air domain, where we had 0 accidents for a decade or two, actually, commercial jet engines, actually, planes. I remember.
Yeah, commercial planes.
Yeah, so they went through that process as well.
That's true.
The only thing here is that whereas people don't necessarily fly all the time, they have to go from one place to another on a daily basis. So that's why this hits them rather directly. And that's why it's a little more concerning to people that when you have tens of thousands of these vehicles on the roads, it's a natural question for them to think, well, what is the level of safety that we should ensure here?
Yes, it's a bit different because, of air travel is very constrained and is in a very, you don't have pedestrians,
Exactly.
out at field.
Yes.
So the human aspects are lower.
Yeah, exactly.
And so I think it's a little, I don't, I don't want to minimize all the progress that have been, happening in the aerospace industry. It's amazing.
Right.
But I think the challenges that autonomous cars are facing are actually an order of magnitude more complex because, as we were discussing here, there is humans in the loop, there is people everywhere.
On any given day, let's say the Atlanta area, we are talking about millions of interactions among the vehicles, some of which are autonomous, some of which are not. And that's part of the challenge.
And we have to be kind to Atlanta. I mean, it's a...
No, I'm just using Atlanta because...
It is,
But having said that, what we learn here is something that they've learned elsewhere.
And I agree. And it's the first question that I think I ask you today. Is like Atlanta is a complex city, and so deploying Waymo here is kind of very interesting to see. One thing that we didn't discuss is that they are still humans in the loop, right? So when these vehicles get stuck, they are humans in the loop. Mm-hmm. Do you have a sense of how much they do and which are the kind of situations where they really, this human control, when the human take control of the car again?
Yeah.
How much of this, has been, what is the progress? What is the progress? You see what I mean?
Sure. Some of these have to also do with training law enforcement agencies too. And so there's a whole... there's a whole discourse in that dimension that's been happening as well. Yeah. How do law enforcement, officers and others, how do they deal with vehicles which are autonomous, which are behaving, in a contrarian way?
Yeah.
So that would be part of it. But coming to this, I'm just going to the example of Waymo and Uber.
Yeah.
My understanding of that is that if the vehicle does something that doesn't make sense, for example, it stops in the middle of the road and doesn't do anything beyond that, doesn't move, then they can reach out to somebody who can remotely handle and then take care of control of the vehicle. Yeah. So that at a very basic level, that capability exists, and then these vehicles, they can take control of them and then possibly they have recourse action, which is meaningful. So I think at least to that extent, we have, even though there's no one physically present in the vehicle, remotely they can access it.
Obviously, we know that Waymo rolled out in Atlanta a couple of months ago. Yeah. And have you had the chance to ride in one, either here in this city or, because you guys travel a lot, anywhere else? And what was your experience?
I actually didn't have a chance. I almost had a chance in Phoenix,
okay.
Because I had to get to the airport, and they were not at that time going to the airport, because they had to go on the highway.
I thought it was your concern about maybe they'll be stuck in traffic. I know a human driver will probably curve around to get me where I need to go.
Sure. So the point there is, it also depends on your trip purpose.
Uh-huh.
So if you had to go to the airport and catch a plane, and you're short of time, then you'd be a little more hesitant doing that.
What I wanted to ask is, a lot of the Uber and Lyft services and way more in a sense are kind of glorified taxis at this point, right? So they serve trips that typically you would take with a taxi. So what I'm wondering is that do you see a use of these vehicles in more public transit settings, right? So Marta now is actually building what we have been pushing for many years, this on-demand multimodal transit system where, kind of the vehicles are doing the first and the last mile.
Right, exactly.
And then, you bring them to high-frequency rail or high-frequency buses. And so Marta now, and I have to give them a lot of credit for this, they are running this system. They are going to run this system for about 5 years in 8 different zones here in Atlanta. The question I have for you is, do you imagine that at some point it will be meaningful, it will be economically viable to have autonomous vehicles do that in a transit system? Because those multimodal transit systems, as we have seen in Atlanta, are game changers for some people. They give access to jobs, access to healthcare that they would not have otherwise. So do you imagine that at some point it's going to be economically viable to have this vehicle be part of a transit system?
I believe so. And I'll give a context here as well. In 2021, we had this large NSF project funded, which is associated with what's called smart and connected communities. And the community we are working with is the city of Peachtree Corners.
Yeah.
And in Peachtree Corners, they have a Gwinnett County Gwinnett County there transit. So they have a couple of routes there, and then in addition to that, you have. They have for just like, I guess, 3 mile stretch, they have an autonomous bus system, So, but it operates only at, I guess, 13 to 15 miles per hour and something. So right now it's much more modest and so on. But the underlying question we had is, if you want to look at cities and if you want the travel to become more sustainable, in the sense that we have seen how bad congestion is in the Atlanta area. So the question we asked is, can we leverage some of these emerging technologies and modes, because we have micro-mobility and other modes as well that we can leverage? Could we get the travel to be more sustainable, where people would, to a certain extent, reduce the amount of travel in their individual vehicles, because sometimes they don't have a choice. The only option they have is to drive their car. So, and so we have been looking at it. We have been working with Gwinnett County, the transit system, the Right Gwinnett, that's what it's called now. And then we have been working with the city, and the city has been working with these autonomous shuttle systems, and they've tried different ones. And one of the questions we looked at is, how can we foster the use of these transit systems? And part of it, as you mentioned earlier, is the first mile, last mile connectivity. And can these autonomous shuttles provide the first mile, last mile connectivity? And that's one. And then for some people, it may also be that we can have micro mobility, like they have these bicycles or scooters, and electric bikes, electric scooters. In fact, at one point there's an electric scooter system where the idea was that at night they would be remotely taken back to areas where they're used during the day, so they can redistribute them, and so that when needed, people can use them. So right now, I think they're looking at a bicycle kind of system in addition to this autonomous shuttle. So what we have been looking at is, what are some of the mechanisms? So how do you enable them? Because it involves public sector, it involves private sector entities, and some of it involves cost as well. So some of these relate to the business models, but some of it also relates to how to operationally make them seamless as well. And so we have been looking at solutions as to where to have these stops, where to have the routes for these buses, so that there are areas where which are lower income, which don't have access to, say, grocery stores as much. I mean, so if you want to go, there's no real recourse for them. There are no bus routes as well. So can we bring those so that we can connect them to the bus routes, so that they can actually go to these grocery stores and so on. So we've been looking at some of those types of solutions.
Very interesting to see that.
Georgia Tech is obviously launching Nexus, a new supercomputer coming here. And how do you feel like this plays in your lab or your work?
I think we're very excited, and I'll tell you the reason for that. So some of the data we collect from multiple sources and multiple, the scale of what we collect when as you get to bigger areas, urban areas, you'll see that the amount of storage, but also the amount of compute power you need is substantial. Because the more compute power that's there, the more you push the boundaries. I mean, that's how we've been doing it, right, as scientific problems and so on. And here what we noticed is that we need to get all the data together so that we can come up with an understanding or a good picture of what the data is telling us. And some of this also needs to be in less than real time. What I mean by that is in milliseconds and so on, or microseconds and so on. Some of that, because if you need to deploy these solutions, we need to be able to do so in a really quick time, actually. So having the compute power and storage that allows us to do that will allow us to test some of these solutions beyond what we do so in the models, in the computers and so on. Yeah. So to see whether they're viable, and if they're not, how do we tweak those solutions to make them more efficient, if you want to call it that. So in both ways. And we are already seeing that, because right now when we do some of the solutions, when we look at our AI-based approaches that we use and so on, we feel like we need more compute power. And so we've been looking at using Pace, but going to that next level, I think definitely is something exciting for us.
Definitely, and I'm looking forward to it. I know we have the AI Makerspace, which Pascal, you're a part of.
I think it's exciting, all this development. I think Georgia Tech is investing in technologies, which I think is critical for enabling not only the research. Right? I mean, obviously your research has to be dealing with a massive amount of compute, like what we do in Tech AI and AI for Up. But I think you mentioned the makerspace. I think that's super important as well, because we want to make, and Srini and I were discussing this, we want also to educate the new generations to these technologies. And I think what we are trying to do with the makerspace now is making it open to as many high school as possible. And, we are not yet there. There are still, some hurdles to go over. Mm-hmm. But roughly speaking, if we can also make these technologies, this computer power, this data storage that we have at Georgia Tech available to high school around the state, I think it would be amazing.
Yes, absolutely.
So, Srini, we're going to play a little game with you. It's called This or That, Tech AI Edition, and we just want to know which one you prefer. So I'll start off with the first 5 questions, and then Pascal will finish us off with the 6th through the 10th question. So now, number 1 is self-driving car or AI personal assistant?
Self-driving car.
Okay. Yeah, that's obvious one. Yeah. Text or call?
Call.
Okay. All right. Cool.
I like that.
Okay. Yeah, I'm a big texter. This is about you. Mac or PC?
Mac.
Okay. Yeah. Mac person. I'm in the infrastructure. Cloud storage or external hard drive?
Cloud storage.
Okay. Yeah, that's good. Robot coworker or human intern?
Human intern.
Okay.
All right, mine, satellite internet or fiber optics?
Fiber optic.
Yeah, that was too easy. Okay. So VR headset or brain-computer interface?
Brain-computer interface.
Okay. Smart city or off-the-grid living?
Smart city.
Yeah. Some people, we figure.
All right, space exploration or deep sea AI research?
Space exploration.
We all want to go to.
You don't want to go down. You want to go up.
Yeah.
Shared mobility systems or personal autonomy?
I'm sorry, what was the first?
Shared mobility systems or personal autonomy?
That's an interesting question. I see benefits from both. So
So you're cheating, but that's okay.
yeah. So I'm sorry. That's the one question I couldn't answer.
I would have done the same. And the last one is you have to answer it right? So Atlanta's traffic or LA's traffic?
I would prefer Atlanta's traffic.
All right. There we go. There we have it. So, Srini, thank you again for joining us for What About AI podcast. We learned a lot, we gained a lot, and again, we appreciate your expertise here.
Yeah, Srini, this was super interesting. I mean, I learned a lot. I'm really happy that you came to talk to us. And I hope, everybody will get some real insight from what you've been discussing here, because this is a very important area.
Yeah.
And I think your insights here have been really, really valuable.
Yeah.
And, looking forward to continue looking at your research, and hopefully at some point we can work together.
Wonderful. Thanks, Pascal, and thanks, Breon. This was wonderful. Thanks for having me, and this was very fascinating for me as well.
Definitely.
Especially the last set of questions. I felt like a student.
Yeah.
Man.
We got to keep it light at the end. We just want to get to know you a little bit more and your preferences. And to our listeners, thank you again for tuning in to another episode. And don't forget to subscribe.
And keep asking, what about AI?
Yeah.